Annually, over 14 million tons of spices are produced, subtly shaping the flavors of the entire world. Among these are spices indispensable to the global food industry. Vanilla, with its sweet, creamy, and harmonious aroma. Cinnamon, which lends a distinct sensation of warmth that spreads through both the oral and nasal cavities. And nutmeg, entirely different in character, possessing a deep, intense fragrance that is slightly numbing. No single spice directly sustains human life. However, were they all to disappear, the global food system, valued at over 10 trillion United States dollars, would be thrown into disarray and face the risk of immediate collapse. Today, we delve inside some of the world's most advanced spice production facilities, where raw materials undergo silent industrial processes that extract essential oils, control aromas, and standardize flavors for billions of dishes every single day. Did you know that cinnamon was once not considered a spice at all, but a luxury equal to ivory, reserved exclusively for royalty and the elite? Most astonishingly, at certain points in history, 1 kilogram of cinnamon was worth several months' wages for a laborer, simply because Europeans at the time had no idea where it actually came from. The tropical rainforests of South and Southeast Asia, including Sri Lanka, India, Vietnam, and Indonesia, are the regions that today supply over 90% of the world's cinnamon production. For thousands of years, the true origin of cinnamon was deliberately concealed to preserve trade monopolies, and it was this very mystery that propelled people out to sea, fueling long-distance sea voyages and the creation of transcontinental trade routes. In the cinnamon industry, at first glance, everything might seem the same, but in reality, there are two fundamentally different approaches to harvesting that correspond to two types of cinnamon and two entirely different end uses. In the case of cassia cinnamon, most commonly used for ground cinnamon, the harvesting process is optimized for speed and volume. The tree is felled once the trunk is fully mature, typically after 10 to 15 years of growth, and a worker then strips the thick bark directly from the tree. Every step is geared towards achieving one goal: extracting as much bark as possible, as quickly as possible, to ensure large-scale industrial production. The result is thick, hard, and powerfully aromatic bark, while the tree itself exhausts its productive life after a single harvest. But the story doesn't end there. The premium Ceylon cinnamon follows an entirely different logic. The cinnamon trees are slender, grow in clusters, and are harvested at a young age. Instead of felling the entire tree, the stems are cut at the base through a process of regenerative pruning, allowing the root system to remain alive and sprout new shoots. This is where the main difference lies. Due to this careful approach, a single Ceylon cinnamon root ball can be harvested multiple times a year, and its productive lifespan extends for up to 40 years. The reward for this patience is exceptionally thin cinnamon quills, naturally curling into dozens of delicate layers, releasing an aroma that is light, sweet, and clean, never sharp or overpowering. Simply put, cassia delivers impact, while Ceylon delivers depth. And it is this depth, this quality that cannot be rushed or mass-produced, that makes Ceylon cinnamon a truly premium spice, small in size but high in value. Upon arrival at a processing plant, cinnamon branches are steeped in water receptacles for at least 15 minutes to soften their fibrous structure, remove surface impurities, and stabilize moisture levels. When the cinnamon stems are ready, a moment arrives that truly defines their value. The bark scraping stage is not just a technological process, but a clear dividing line between premium and low-grade cinnamon, perhaps more critical than cultivation or drying. A worker holds a specialized knife with a short, curved blade sharpened to a very narrow angle, guiding their hand with millimeter precision so that the blade glides along the delicate inner bark rather than chopping or cutting downwards. This inner layer is typically only about 0.2 millimeters thick. So delicate, in fact, that even a fraction of a second of excess pressure will tear the bark and destroy its commercial value. After scraping, the thin layers of cinnamon bark are processed immediately while still moist, and are then rolled around a central core of bark, forming a cinnamon quill. The reason is simple. Each layer is only a few tenths of a millimeter thick, far too thin to hold its structure once dried. The worker selects bark strips with uniform moisture levels and lays them overlapping along the grain for even shrinkage distribution. Typically, 8 to 12 layers are collected, which is sufficient to reach a standard thickness of about 3 millimeters, while also creating a hollow structure that helps preserve and retain essential oils. Through this technique, the cinnamon quill naturally twists as it dries, forming a smooth, light, yet robust tube. If this step is skipped or performed incorrectly, the bark becomes distorted, cracks easily, and is almost impossible to transform into premium cinnamon sticks. Once laid, the cinnamon sticks proceed to the controlled drying stage. Rather than being exposed to direct harsh sunlight, they are placed on multi-tiered drying racks indoors or under awnings where light is diffused and air circulates evenly. This process typically lasts for about 7 days, depending on weather conditions. The goal is not to completely dry the cinnamon, but to reduce the moisture content to approximately 10 to 12%. Dry enough for storage, yet still retaining the essential oils. Throughout this period, the bark layers slowly contract along the grain, causing the sticks to naturally curl into quills. If the drying is too rapid, the essential oils will evaporate. If too slow, the cinnamon can become moldy or deformed. When executed properly, the cinnamon reaches a stable state and can be sent thousands of miles overseas while still retaining its original aroma. Once the drying has achieved the required standard, the cinnamon is sorted by length, degree of curl, and the radius of each quill. These are the key factors determining the commercial value of each stick. After sorting, the cinnamon moves to the cutting stage, where the agricultural product begins to be standardized into a commodity. Bunches of cinnamon are aligned and cut to standard lengths, typically ranging from 5 to 20 centimeters. Longer pieces are bulk packed for wholesale distribution, while sticks shorter than 3 inches are allocated for retail sale. This stage demands decisive yet precise handling, as even a slightly uneven cut can cause the delicate bark layers to splay, resulting in the stick losing its form and diminishing its quality. Due to this stringent requirement, cutting productivity remains limited. Each worker handles only a few dozen bunches per hour. In return, the finished cinnamon achieves uniform sizing and is fully prepared for packaging, shipping, and global export. Following drying, a portion of the cinnamon is directed to the grinding process. Prior to grinding, the cinnamon is not processed immediately. Instead, its moisture content is checked and stabilized below 12% to prevent mold and ensure that essential oils do not degrade in subsequent stages. Once this condition is met, the cinnamon enters a closed grinding system. The sticks are gradually pulverized, passing through multiple stages of blades and rollers within an environment where the temperature is consistently maintained below 40 degrees Celsius. Maintaining a low temperature is critical because once cinnamon is pulverized into powder, its surface area increases dramatically, making the essential oils far more prone to evaporation than in whole sticks. For this reason, fresh ground cinnamon powder does not remain exposed. It is immediately sieved to remove coarse particles, refined to a uniform fineness, and then immediately packaged and sealed. As we depart from the cinnamon processing factories, where the warm, spicy aroma still lingers in the air, our next stop is Indonesia, a tropical country characterized by its hot, humid climate, fertile volcanic soils, and vast archipelagos stretching across the equator. These environmental conditions are nearly perfect for cultivating nutmeg. Today, Indonesia accounts for approximately 60% of the world's nutmeg production, establishing it as the paramount hub for this spice. Nutmeg, often referred to as the fiery jewel of the spice world, stands as one of the very few spices whose harvest time is dictated solely by the fruit itself. When the outer pericarp fully matures, it naturally splits open, revealing the nutmeg seed and a vibrant crimson, web-like aril wrapped around its core. This is the sole signal that authorizes harvest. Nutmeg trees can grow up to 15 meters tall, well beyond human reach. When the fruit reaches full maturity, farmers utilize long poles equipped with a sickle-shaped blade at the end to hook and pull at the stem, causing the fruit to fall to the ground, where it is then rapidly collected. Crucially, the harvesting window for each fruit lasts only about 24 to 48 hours from the moment the pericarp begins to crack. Any delay beyond this point leads to a rapid decline in quality. The pressure intensifies during the rainy season, when harvesters must inspect each tree daily, navigating slippery trunks and constantly contending with the threats posed by red and fire ants. In the case of nutmeg, precision is not an advantage, it is a requirement for survival. Following collection, the nutmeg fruits are gathered and thoroughly washed to remove dirt, sap, and any insects clinging to the surface. This seemingly simple step helps mitigate the risk of fungal infections from the outset and readies the fruit for precise cleaning in subsequent stages. Once cleaned, the nutmeg is meticulously dehusked by hand to extract its most valuable core, the nutmeg seed. This is the part that holds the highest concentration of the essential oils responsible for the spice's warm, pungent aroma and the depth of its flavor. During this process, the worker must also carefully remove the red aril, known as mace, a delicate, web-like layer that clings tightly to the seed. Mace is itself a spice and highly prized, but its fragility makes this task exceptionally difficult. The slightest lapse in pressure can tear the mace and easily damage the seed beneath it. A minor crack in the seed can reduce its commercial value by 40%. While its appearance may remain almost unchanged, an intact nutmeg seed can retain its aroma for up to 4 years, whereas a scratched or damaged seed may lose its fragrance in just a few months. Post-separation, the two parts of the nutmeg embark on different journeys. The red aril, or mace, is shade-dried in well-ventilated conditions for several days to preserve its color and aroma. Meanwhile, the nutmeg seeds must be air-dried or gently kiln-dried for 8 weeks until the moisture content is reduced to a safe level. Throughout this time, the hard shell naturally cracks, and the essential oils fully stabilize. Once the nutmeg seeds meet quality standards, they are collected and undergo final cleansing before moving to the stage that ultimately defines their aroma: grinding. Unlike many other spices, nutmeg allows for virtually zero margin of error. The moment the temperature rises above 45 degrees Celsius, key aromatic compounds begin to rapidly evaporate, causing the seeds to lose their fragrance even before they are pulverized. For this reason, the entire grinding process takes place in a sealed, temperature-controlled environment where speed is deliberately sacrificed for aroma preservation. The seeds are ground in multiple stages until they reach a particle size of just 60 microns, finer than premium wheat flour, allowing the aroma to evenly disperse from the very first use. The powder is then sieved, quality-checked, and hermetically sealed to preserve the essential oils and extend its aromatic lifespan. At this point, the nutmeg's journey is nearly complete. From a small fruit in the rainforest to a sophisticated spice capable of retaining its aroma for years, ready to make its appearance in kitchens across the globe. Vanilla, renowned as the second most expensive spice in the world after saffron, was once valued at the equivalent of a gold bar per kilogram. Nevertheless, vanilla is more than just a spice with a staggering price tag. It is also a strategic ingredient underpinning the entire global confectionery, beverage, and premium food industries. With vanilla, harvesting is not merely a matter of collecting pods. It is a fierce race against time, humidity, and even other people. Its high value makes vanilla a constant target for theft, leading many farms to acknowledge the reality that approximately 10% of their annual harvest disappears each year before the pods leave the field. Vanilla reaches its peak quality within a very narrow window of ripeness. Harvesting too early results in weak flavor, while delaying by even a day in humid conditions can cause mold and reduce a pod's value by half. For this reason, each vanilla pod is hand-picked with a small knife, requiring a speed that is matched by absolute precision, and is immediately collected and transported the same day to prevent any uncontrolled fermentation from beginning. As the bags of vanilla arrive at the processing plant, they immediately enter a strict securitization system. The entire facility is surrounded by barbed wire and monitored 24 hours a day by surveillance cameras to deter theft. In its raw state, vanilla pods are hard, brittle, and almost entirely odorless. To awaken the hidden flavor within, the pods must undergo a hot water blanching stage. This brief yet precisely controlled application of heat softens the pod's structure, while simultaneously halting natural growth. More importantly, it triggers a chain of enzymatic reactions within the pods, initiating the formation of characteristic flavor compounds. Among these compounds, vanillin is the dominant component, accounting for around 90% of vanilla's signature taste. Following blanching, the vanilla pods enter the sweating phase, during which they begin to develop their dark brown color. This process reduces moisture, concentrates flavor, and allows vanilla's distinctive sweetness to develop. While the pods are still warm, they are placed into wooden boxes lined with several layers of blankets to retain heat for as long as possible. The boxes are then sealed for 48 hours. By the end of this stage, the pods have darkened significantly and are ready to transition to the curing phase. Vanilla's curing process consists of two stages: sun curing and shade curing. This phase is crucial for the full development of the pod's flavor and rich color. Vanilla pods are laid out evenly on cloths and exposed to sunlight for 3 to 5 hours daily over many consecutive days. To ensure even drying, they are frequently turned. During the curing process, skilled workers gently massage the pods to encourage the release of essential oils and enhance their aroma. However, the pods cannot be left in the sun all day, as vanilla needs to retain a certain level of moisture for its flavor to further develop. After sun curing, the pods are covered overnight and put away, only to be brought back out into the sun the following day. After approximately 10 to 15 days of sun treatment, the vanilla pods are moved to a well-ventilated shaded room, where they remain for 2 months. Upon completion of the curing process, the vanilla pods undergo strict sorting based on length, flexibility, color, and aroma. Pods that meet quality standards are tied into small bundles and secured with twine to maintain their natural shape and prevent cracking during transport. However, not all cured vanilla is valued equally. Of the total production, only around 20 to 30% of the highest quality pods are selected for the process of producing natural vanilla extract. This is the most economically valuable product in the vanilla processing chain. The remaining pods are typically sold as dried whole vanilla or used to flavor lower-grade products. What is even more striking is that in a global market with a massive demand for vanilla, approximately 95% of products labeled vanilla contain no real vanilla at all, relying instead on synthetic flavorings. This reality makes each properly cured, natural vanilla bean not only rare, but a true embodiment of time, craftsmanship, and months of patience. In these expansive fields, you will witness modern machinery efficiently harvesting celery. These machines are equipped with ultra-fine horizontal blades that operate close to the ground. They meticulously cut the celery stalks at the base, ensuring no damage to the stalks or leaves. The blades operate with high precision and smoothness, guided by advanced sensors to ensure a clean and uniform harvest across every row. Immediately after cutting, the celery is gently placed onto an integrated soft conveyor. This system carefully transports each stalk to a preliminary cleaning area, where dirt and debris are removed using air blowers or rotating brushes. This process helps keep the celery fresh and clean from the very first stage of harvest. Next, the celery is carefully packed into large baskets. These baskets not only protect the celery from damage, preserving its freshness and integrity, but also facilitate its transport to the processing plant. At the plant, the baskets are easily unloaded and set onto modern production lines, ready for thorough cleaning, packaging, or further processing. Modern harvesting machines have had a significant impact on improving agricultural efficiency, especially in the vast fields of celery production. These machines can cover tens of acres per day, saving time and labor, while also reducing the strenuous workload that previously required numerous workers. They are designed to operate quickly and precisely, ensuring that each celery stalk is harvested uniformly without any product damage. The use of machinery also aids in lowering long-term production costs, giving farmers a competitive edge in the market. Furthermore, the advanced technologies integrated into these harvesting machines not only protect the crops, but also help maintain high productivity to meet growing consumer demands. This represents a significant leap forward in modern agriculture, bringing benefits that are both economic and environmental. While modern machinery leads the way in agricultural mechanization, some farmers still rely on traditional hand harvesting methods. However, the combination of manual labor with specialized auxiliary equipment has led to remarkable improvements. This approach optimizes labor efforts and speeds up the harvesting process, all while retaining the flexibility and gentleness that only human hands can provide. Modern machines are designed to support workers as efficiently as possible. The top part of the machine offers spacious areas for workers to sit or stand comfortably, reducing fatigue as they move across large fields. On either side of the machine are two long booms equipped with automatic conveyor belts, allowing workers to easily place celery onto belts after cutting, optimizing the entire process. Once the celery stalks are neatly cut, they are moved onto the conveyor belt, where built-in water sprayers provide an initial rinse, removing dirt and debris on the spot. Following this, workers pack the celery directly into bags or tie it into bundles. These bunches are then placed into large baskets at the rear of the machine, convenient for transport to processing stations or factories. Celery is a delicate vegetable that is easily bruised and requires gentle handling to maintain its appearance and freshness. This is where manual labor becomes indispensable. Workers can inspect each stalk individually, ensuring that only celery meeting quality standards is selected. Hand harvesting is particularly valuable in smaller fields or for premium-grade celery where attention to detail is crucial for consumer satisfaction. Skilled workers can make adjustments that machines cannot, such as removing damaged leaves or packing celery carefully to prevent bruising during transport. The combination of machinery with manual harvesting also provides flexibility in areas where terrain or weather conditions might limit the efficiency of machine operations. Humans can step in to ensure the harvest is completed without delay. Furthermore, this method supports sustainable farming practices by reducing waste, as workers can selectively harvest celery based on its ripeness, rather than relying solely on machines that may harvest indiscriminately. The synergy of machine precision and human oversight upholds the broader goals of sustainable and high-quality agriculture, ensuring that celery harvesting continues to meet the demands of modern markets. Once the celery arrives at the processing facility, it undergoes a thorough processing procedure to ensure it meets the highest standards. Firstly, the celery is unloaded and moved to a cleaning area, where high-pressure water jets remove any remaining dirt or impurities. It is then sorted and inspected, with any damaged or substandard pieces being removed. Following this, the celery is trimmed and cut into appropriately sized portions depending on its intended use. Finally, it is freshly packaged, ready for distribution and delivery to consumers. Modern machinery works closely with human oversight in the processing stages of celery. Machines perform tasks such as washing, trimming, and packaging with high speed and precision, ensuring efficiency and uniformity while preserving the celery's freshness and crispness. Automated systems are capable of handling large volumes in a short time, significantly reducing manual labor. Simultaneously, human inspection plays a vital role in quality control, identifying and removing any damaged pieces that might be missed by machines. This collaboration ensures that every stalk of celery meets the highest standards of quality and safety before reaching consumers. As late summer arrives, farmers in California meticulously prepare for the sowing of celery seeds, ensuring the highest quality seedlings ready precisely on time for the season. But how exactly does this seedling cultivation process work? Join us as we explore the fascinating journey of celery seedlings in modern nurseries. The process of growing celery seedlings in nurseries is carried out using fully automated machinery, ensuring precision and high efficiency. First, seedling trays are placed on a preparation line, where they are thoroughly cleaned and inspected. An automated system then fills each tray with loose, aerated soil, measured with high precision to create the ideal environment for seeds to germinate and develop. Once the soil trays are ready, a cutting-edge seed sowing machine accurately places each tiny celery seed in its designated spot, ensuring correct spacing and depth. Afterward, the trays are moved to an automated irrigation system, where precisely misted water maintains soil moisture, guaranteeing perfect conditions for seed germination. This process operates continuously and efficiently, allowing thousands of trays to be processed daily with consistent quality. After approximately 30 to 40 days, the celery seedlings have grown strong and healthy, reaching a height of 10 to 15 centimeters, and are ready to be transplanted into the fields. These seedlings mark the beginning of a bountiful harvest, laying the foundation for lush, green fields of celery. Once the celery seedlings have been cultivated in the nursery, the next step is ground preparation, the place where they will transform into vibrant celery plants. Specialized soil cultivation machinery loosens and aerates the topsoil, making it more porous and ideal for root growth. Following this, the machinery levels the ground and creates neat rows, ensuring that seedlings are planted in straight lines, which makes irrigation more efficient and fields easier to manage. As soon as the ground is ready, modern transplanting machines come into play. Workers sit in designated seats on the machine, carefully lifting seedlings from their trays and placing them onto the machine's conveyor system. The conveyor then moves the seedlings to mechanical arms that gently plant them into the soil at precise depths and spacing. With this thoughtful design, the machine ensures that each seedling is planted in straight, evenly spaced rows, optimizing field space and creating the best conditions for celery growth. Throughout the growth process, plants are supplied with water, and essential nutrients to promote healthy development. Before we delve into the harvesting process, let us appreciate the diligent effort that goes into cultivating garlic. This hardy plant begins its life as a single clove, planted in nutrient-rich soil. Garlic thrives in cool weather. In fact, it flourishes under the blanket of snow. It is, perhaps, a truly rugged love. Farmers meticulously prepare the land, tilling it to perfection and ensuring the soil has good drainage. Garlic cannot tolerate waterlogged roots, so excessive watering is strictly prohibited. Planting garlic with industrial seeders is a revolutionary solution for modern agriculture. These specialized machines, blending precision and efficiency, are equipped with compartments for garlic cloves which are evenly distributed and dropped into pre-dug furrows as the machine moves across the field. The depth and spacing of plantings can be adjusted according to the crop's specific needs, ensuring optimal growing conditions. As the cloves are planted, the machine simultaneously covers them with soil, eliminating the need for manual labor. Furthermore, the uniformity achieved with these machines ensures that each clove has ample space and nutrients to develop into a healthy bulb. Once the cloves are nestled into their cozy soil beds, farmers enter a phase of anticipation. Garlic requires anywhere from 6 to 8 months to mature, and during this time, it needs occasional watering and vigilance to keep weeds and pests at bay. It is a low-maintenance plant, but do not let that fool you. Farmers must meticulously time the entire process for the bulbs to grow large and flavorful. Harvesting garlic is no simple feat. It is a race against time to collect the bulbs at the opportune moment. If harvested too early, the result will be small cloves. If one waits too long, the bulbs may burst open in the ground, making them less marketable. Industrial garlic harvesting has revolutionized the way this vital crop is gathered. Combining efficiency with innovation, lightweight garlic harvesting machines serve as the initial step in this transformation. These compact devices dig into the soil and lift the bulbs to the surface, leaving them neatly exposed on the ground. Once the garlic is unearthed, farmers manually gather the bulbs, a process that, while requiring human effort, is significantly faster and less labor-intensive than traditional manual harvesting. For larger operations, more sophisticated machinery takes center stage. These advanced garlic harvesters feature conveyor belts that not only excavate and lift the bulbs, but also transport them directly into collection hoppers or truck beds. This seamless process eliminates the need for manual collection, reducing labor costs and vastly improving efficiency. With these machines, thousands of tons of garlic can be harvested in mere days, a task that would have taken weeks using traditional methods. This streamlined approach ensures that garlic moves from the fields to the market swiftly, preserving its freshness and quality. The use of industrial equipment in garlic harvesting not only saves time and effort, but also marks a significant leap forward in modern agriculture, making the process more sustainable and cost-effective for farmers. Once the garlic is harvested, it makes its way to factories, a bustling world of cleaning, peeling, cutting, and packaging. Here is a breakdown of how it all happens. The initial step involves farmers inspecting the bulbs, removing the outer layers still covered in dirt and dust. This is followed by a sorting process, where the garlic is graded and packed into boxes. While machines perform the heavy lifting, such as moving the garlic and sorting it by size, the expertise of workers adds a crucial layer of quality control. Their ability to work in sync with the automated system allows for quick decision-making and decisive action. The conveyor belt moves swiftly, but the hands of a worker move faster, ensuring no defective garlic is missed. This harmonious interplay between human dexterity and machine efficiency makes the sorting of garlic so effective and ensures that only high-quality cloves proceed to the next stage of processing. Some of this garlic is ready for direct delivery, while a significant portion undergoes further processing to ensure premium quality. Advanced processing begins as garlic enters a vibrating system and rotating drums designed for peeling. This stage effectively removes the outer layers of the bulbs and separates them into individual cloves. These cloves are then conveyed along a belt to an inspection area where human workers manually assess for quality, removing any defective or unsuitable parts. Next, the cloves pass through a series of powerful air jets and vibrating machines to thoroughly remove any remaining skin. As the cloves travel along the conveyor belt, air jets blast them with controlled streams of air, dislodging stubborn pieces of skin clinging to the surface. Simultaneously, vibrating machines create a gentle yet effective oscillating motion, ensuring that the cloves are evenly exposed to the airflow and further loosening any residual layers. This dual system not only guarantees a thorough peeling process, but also prevents damage to the delicate cloves, preserving their integrity and quality. The equipment is designed to handle large volumes of garlic efficiently, making it ideal for high-throughput production lines. By automating this traditionally labor-intensive step, the system significantly speeds up processing times, reduces manual labor, and ensures consistent results. The peeled cloves remain impeccably clean and ready for the next stage of cleaning or packaging, meeting the highest standards of quality control and hygiene. Subsequently, the garlic passes through a water spraying system, which ensures its final, thorough cleansing. Once the cloves are impeccably clean, they are collected and directed to automated packaging lines, ensuring they are neatly packaged and ready for distribution. In addition to fresh garlic, some factories also produce roasted garlic. After meticulous cleaning, the cloves are conveyed to heating and roasting systems. Following roasting, the garlic passes through a vibrating machine designed to remove any residual dust, ensuring the product is hygienic and ready for immediate consumption. Roasted garlic possesses a unique, rich flavor that enhances its appeal, making it a flavorful addition to various dishes. This meticulous and efficient process not only ensures that the garlic meets the highest standards of cleanliness and quality, but also prepares it for diverse markets. Whether destined for grocery store shelves or further processing in factories, each clove is handled with precision, making its journey from field to table a remarkable feat of efficiency. Garlic is not just a culinary delight, it is big business. With a global production exceeding 28 million tons, garlic generates billions of dollars annually. Garlic has deep roots in culture and folklore. It is the unsung hero that transforms bland dishes into mouth-watering extravaganzas. From the fields where it is grown to the factories where it is processed, the journey of garlic is truly extraordinary. It is a testament to the diligent work of farmers and the marvels of modern technology. The next time you slice a clove of garlic, take a moment to appreciate its story, a story of resilience, flavor, and a touch of magic. So, what is your favorite way to enjoy garlic? Whether it is roasted, minced, or transformed into delectable garlic butter, let us give this humble bulb a well-deserved ovation. Ripe red tomatoes are carefully lifted to avoid any bruising or damage. Then, a shaking system is activated, creating steady vibrations strong enough to detach the tomatoes from their stems without compromising their quality. Simultaneously, a rear fan system kicks in. A powerful yet controlled airflow sweeps away leaves and small twigs, leaving behind only the juicy, ripe tomatoes. Any green or damaged fruit is automatically nudged off the conveyor belt and into a rejection zone. The vibrant red tomatoes continue to flow smoothly along the main conveyor, forming a crimson river. A single modern machine is capable of harvesting up to 15 tons of tomatoes per hour, making the entire process astonishingly quick and efficient. Incredible, isn't it? The selected tomatoes roll towards the end of the conveyor belt, where a mechanical arm extends from the side of the machine. The stream of tomatoes pours into an awaiting trailer. One by one, trailers are filled with the succulent red tomatoes, ready for the next stage of their journey, the factory. Post-harvest, thousands of fully loaded trucks rumble towards the processing plant, carrying mountains of ripe red tomatoes. At the factory, trailers brimming with tomatoes are emptied into massive bubbling water tanks. Gentle streams of air bubbles rise through the water, softly massaging each tomato, aiding in the removal of stems, dust, dirt, and other surface debris. This process not only cleans the tomatoes but also protects their delicate skin, preserving their freshness and vibrant red color. Following the initial soak, the tomatoes are moved onto a conveyor and pass under high-pressure water jets. These powerful streams wash away any remaining dirt, ensuring each tomato is sparkling clean and ready for processing. With a capacity of up to 20 tons of tomatoes per hour, this stage is both highly efficient and essential for maintaining product quality at the industrial scale required for ketchup and tomato sauce production. The gleaming red tomatoes flow along the conveyor in steady waves, forming a living sea of red, ready for the next stage of transformation. After washing, the tomatoes go through an automatic sorting system. Color sensors and laser scanners detect and remove any bruised, rotten, or unripe tomatoes. Using air jets or mechanical manipulators, the system discards defective fruits from the conveyor belt. Meanwhile, factory workers conduct a final inspection, ensuring only perfectly red, ripe, and uniformly sized tomatoes proceed to the next processing stage. Once sorted, the tomatoes are sent into a steam blanching system, heated between 85 and 90 degrees Celsius for nearly 1 minute. The hot steam softens the skins, making them easier to remove without losing essential nutrients, while preserving the fruit's natural color and flavor. Immediately after, the tomatoes are rapidly cooled in cold water to halt the cooking process and maintain their freshness. This cooling process also aids in more efficient skin removal. Next, the tomatoes are transferred to a conveyor belt equipped with specialized rollers that gently peel away the skins without damaging the pulp, ensuring high quality for subsequent processing stages. After being deseeded, the tomatoes are sent to industrial grinders, where they are transformed into a thick, homogeneous pulp. Stainless steel blades spin at high speeds, pulverizing the fruit into a stable, rich mixture. This pulp then passes through a specialized filtration system, which removes seeds, fibrous material, and pulp. This leaves a silky smooth blend of tomato solids and juice, the golden base for creating tomato sauce and ketchup. In the production of tomato sauce, the tomato pulp and juice extracted after grinding are transferred into large cooking kettles. The mixture is simmered at temperatures between 85 and 95 degrees Celsius for approximately 1 hour to deepen the flavor and evaporate excess moisture. Compared to ketchup, tomato sauce is cooked for a longer duration to retain its natural texture and original flavor. As the mixture thickens, ingredients such as olive oil, salt, sugar, minced garlic, and herbs are added to enhance the sauce's natural flavor profile. After cooking, fine filtering, and seasoning adjustments to achieve the perfect taste, the tomato sauce is immediately transferred to a sterile packaging area. Before coming into contact with the sauce, all glass bottles or tin cans must undergo a thorough cleaning. Once the packaging is ready, a dispensing system is automatically engaged. Through smart dispensing technology, each bottle or can is filled with a precisely measured amount of tomato sauce, ensuring consistency and preventing overfilling or underfilling. After filling, the containers pass through a vacuum sealing machine. Removing all air from the packaging helps prevent oxidation and limits microbial growth. Immediately after, the bottles or cans are hermetically sealed with a heat press or an automatic sealing device. Even though the process has been thorough up to this point, to guarantee absolute food safety, the sealed products are then sent to a high-temperature sterilization system. Finally, the delicious bottles of tomato sauce are neatly organized and moved into cold storage rooms maintained between 4 and 10 degrees Celsius. Due to the cool and dry environment, the sauce can retain its full flavor, color, and quality for 6 to 12 months, ready to be served with everything from home-cooked meals to large-scale commercial kitchens. During ketchup production, the tomato pulp and juice are cooked at higher temperatures, but for a shorter duration compared to tomato sauce, approximately between 90 and 100 degrees Celsius, for about 45 minutes. This method helps to preserve the fresh and tangy flavor of the ketchup. Heinz's legendary status is often attributed to its perfectly balanced recipe. It is believed to consist of 72 to 75% concentrated tomatoes, 12% distilled vinegar, 10% pure cane sugar, and other natural ingredients. This combination creates a distinctively sweet, tangy taste and a velvety texture that is hard to match. Once the cooking is complete, the ketchup is sent to a high-pressure homogenizer to achieve a perfectly smooth and uniform texture. After a rapid cooling process, Heinz ketchup moves to its final stage: packaging. Plastic bottles are the most common packaging format for Heinz. An automatic precision dispensing system fills each bottle with ketchup with high accuracy, ensuring consistent volume and quality for every unit. Then, a screw-on cap or a flip-top lid with a tamper-evident seal is applied and securely fastened to preserve freshness and prevent air entry. The bottles are then labeled, and the production and packaging dates are printed onto them using an automated marking system. Thanks to this meticulous and hygienic packaging process, Heinz continues to deliver consistent quality and its signature taste unchanged for over 150 years.